we're going to look at solving linear systems using the substitution method. Now, if you remember when we were graphing, the intersection point is where the lines will meet. Okay, the solution of that system of linear equations is the point of intersection. And what is a system? Well, that's when we have two or more lines. So we're going to solve this time, instead of graphing it and seeing where they meet, we're going to solve it in one way in which we can do algebraically using the substitution method. Okay, so here's the steps you can always go back to. You can pause the video to see it. We're going to solve one equation for one variable, and then we're going to substitute in the other equation, and then we're going to be able to check our solutions. Okay, so in number one, we have one variable already by itself. Okay, so we don't have to do anything. That's our first step. I call that the revised equation. In this situation, it's already set up for us. So what we're going to do is we're going to substitute, which is why it's called substitution method, into the other equation. So everywhere I see a y, I'm going to put 4x plus 11. So that gives me 3x minus. Now this is where I stop, and instead of writing y, I'm going to put 4x plus 11 is equal to negative 7. Now I'm just going to do some algebra. So I have 3x minus 4x minus 11, right? Because we have to distribute that negative sign, is equal to negative 7. So that gives me negative x minus 11 is equal to negative 7. I add 11 to both sides, and I have negative x is equal to positive 4. Divide both sides by negative 1, and x is equal to negative 4. Okay, so I need to find y now. So I have x is set up. Here again is that revised equation. It has it nice and easy set up for me for y equals. So I have y is equal to 4 times negative 4 plus 11. So that gives me negative 16 plus 11. So y is equal to negative 5. Okay, so our solution to the linear system is going to be negative 4, negative 5, right? Because we always list it alphabetically. Now, the other thing we can do is we're going to check it in this case. But if we were to graph those two lines, put them in slope-intercept form and graph them, that's where they would intersect. Okay, so again, check it just like we did previously in previous lessons. I'm going to start with my original equation, and I'm going to substitute in my values. So y is equal to negative 5. This is my solution. 4, and then 4 times our x is negative 4. Plus 11, so we have negative 5 is equal to negative 16 plus 11, which is true. Now we're going to start with our other equation, which is 3x minus y is equal to negative 7. So I have 3 times negative 4 minus a negative 5 is equal to negative 7. So it's negative 12 plus 5 is equal to negative 7. That's also true. So we know that this point is on both lines, so it has to be the point of intersection. Okay, moving on to the next type. If you look at these equations, they are both set equal to y. So in a way, they're both set up as revised equations, but think about this. If this expression is equal to y, and this expression is also equal to y, then those expressions must equal each other. Again, the other way to look at that is I'm basically substituting, right? I'm taking 1, and I'm saying, okay, well, I'm going to substitute this in for that y right there. So no matter how you look at it, that's how you can set up your equation. So I'm going to solve for x. And I have 1 is equal to 4x minus 3. Add 3 to both sides. And I have 4 is equal to 4x. So x is equal to 1. Okay, I can use either equation. I'll use this one. I have y is equal to x is 1. Minus 3, so y is equal to negative 2. So my solution to my linear system is 1, negative 2. Okay, moving on. In number 3, now we don't have an equation that's set up exactly where x or y is by itself. So we have to look at this, and I realize that right here in this second equation, I have x with the coefficient of 1. So that's the easiest one to get by itself. So I'm going to solve for x. And I have x is equal to negative 4y plus 18. Okay, so now again, I'm going to go to this is my revised equation. I'm going to come back to that revised equation. And everywhere I see an x, I'm going to substitute in this expression. So I have 5 times. Now I'm going to stop, and I'm going to substitute in negative 4y plus 18. I'm going to keep going now with this equation right here. Minus 3y is equal to negative 25. So that gives me negative 20y plus 90 minus 3y is equal to negative 25. All right, now I'm just going to keep going and I'm solve for y. So I have negative 23y plus 90 is equal to negative 25. I'm going to move that 90 to the other side, and I have negative 23y is equal to negative 115. Divide both sides by negative 23, and y will equal positive 5. Okay? Now, I'm going to go back to this revised equation because I need to know what x is. So x is equal to negative 4. I've already solved that y is positive 5 plus 18. So x is equal to negative 20 plus 18. So x is equal to negative 2. So I have negative 2 and positive 5 is my solution to the linear system, which would be the point of intersection. Okay, if you want to take the time to check it, you can. You can pause the video and check it, but we're just going to keep moving to get to all the different types of problems we have. Okay, and looking at our next equation, we already have y by itself, so I'm going to substitute that into the other equation. So that gives me 6x minus, so now I have 2. Now I'll substitute what I have in for y. 3x plus 1 is equal to negative 2. So it gives me 6x. Now I'm going to distribute that negative 2. I get negative 6x minus 2 is equal to negative 2. I combine my terms, and I have negative 2 is equal to negative 2. So now this one's a little different. When I solved it, I didn't get an x. So I just kind of got down to the end. So negative 2 equals negative 2. That's a true statement. So what does that mean when we get to that point? It means if I were to graph these lines, it would be the same exact line. So at this point, we're going to say that this is infinite solutions, meaning they're touching in an infinite number of times because they are the same line, which is why we got to here and we have a true statement. So we know that's infinite solutions. All right, let's take a look at the next one. Same sort of idea. I already have y set up by itself. So I have 5x minus, and there's my expression, 5x minus 4 is equal to negative 4. So this gives me 5x minus 5x plus 4 is equal to negative 4. This is going to zero out. And I have 4 is equal to negative 4, which is false. This is not true. So what does that mean? It means that there's no solution. Doesn't matter what values you put in there, you're not going to get a true statement. No solution. And again, if you remember from when we graph, when do we have a no solution? It's when the lines are parallel because they never touch. All right, let's look at our last one. We're going to do a word problem, and we're going to use a system. So it says Tony's pickle cart sells pickle spears for $1 each, and the jars of pickles are $7 each. Last week, he sold a combined total of 322 spears and jars for $592. How many spears and how many jars were sold? So what I like to do in the beginning of these word problems, it just helps so it doesn't get so overwhelming. Just make a list. It's hard to look at a couple sentences and come up with what's going on. So I make a list. I know that the spears are $1 each. I know that the jars are $7 each. I know that 322 items were sold. I know the total sales was $592. And I'm going to set X and Y equal to what I have here. X is the number of spears and Y is the number of jars. Okay, so we have two types of equations. We're talking about quantity, which is how many things are. And then we have a money equation because we're definitely talking about money here. So let's see what we have. Quantity is how many. I know here it says that we sold 322 items of spears and jars. So when we look down here, our spears is X, the number of spears is X, and the number of jars is Y. So when I add them together, I'm going to get 322. Now, when I look at our money, we know that spears are $1 each. So I can make that 1X or just X. And then my jars are $7 each, and jars is Y. And I know that we sold a total of $592. That was our total sales. Okay? So again, in double checking, this is how many, and this is money, money, money to make sure we have things in the right spot. Okay, so again, we can use substitution. In this case, I'll solve for y. You can solve for x if you like, doesn't matter. I have y is equal to negative x plus 322. I'm going to go to my other equation. Now, anywhere I see y, I'm going to substitute in my expression there. So I have x, or 1x, plus 7 times negative x plus 322 is equal to 592. Okay, so I'm going to keep going. So I have x minus 7x, and I'm going to multiply 7 times 322, and I get plus 2254 is equal to 592. Okay, here this gives me negative 6x. I'm going to bring that 2254 to the other side, kind of all in one step. And that gives me negative 1662. I'm going to divide both sides by negative 6. So I know x is equal to 277. Now again, I'm going to go up and I'm going to substitute in so I can get my value for y. Negative 277 plus 322, so y is equal to 45. And now I have to answer the questions. The question is, how many of each were sold? So x I know is the number of spears. So we're going to say 277 pickle spears were sold, and 45 jars of pickles were sold. Now, again, remember, in this sort of a word problem, we know we can't get a negative number because you can't sell a negative number of items. I also could not have, unless it specifies, I can't have anything with a decimal or a fraction because I'd have to sell them as a whole. Okay, thanks so much for stopping by today. You have a great day.